Hi, everyone, and good morning, and welcome to another session of this series that we have started last week. This is myself, Abhijeet, with my team, and we are doing this session every Saturday, 10 a.m. IST. Started last week on 30th April, and will be going till 16th of July. And the series is about how to take up the AZ-204, which is the certification that we are currently targeting. So this is something which we have started. This is a guided course towards the Microsoft certification for AZ-204, which is a developer associate for Azure. So let's begin. So as mentioned, this is me, Abhijit, and I'm a product and technology solutions architect in 365 Technologies, and I'm currently pursuing along with you this course on Azure developer and AZ-204, the certification that me and my team are also pursuing. And we're just sharing our experiences with you so that it can help everyone who is trying to do the same with us. So just a quick overview of what this session today is all about. We are targeting the second module in the series of 12, which is implementing Azure Functions. So this Azure Function, the concept of Azure Functions is very neat. It's a very flexible and a very easy concept to understand and implement. When I started looking at this, I found this to be a very useful tool or a tool that Azure has for us developers to offer. So this is something that we are going to see today. And after the session, if there are any questions that you have or any feedback, we'll be open for those. So let's start with the session of series as a module 2 for AZ-204, developing solutions for Microsoft Azure. And just a quick recap of our series schedule. So today is the one which we are doing, which is on implementing Azure Functions. And the following are all the scheduled sessions that me and my team will be doing. And looking forward to see you all on all those sessions. So this particular module that we are targeting today, this is related to Azure Functions. So now, if I say what an Azure Function is, so an Azure Function is a serverless resource that Microsoft uh, provides you through its Microsoft Azure portal. And this serverless resource or infrastructure that we get, it allows us to create web-based endpoints or web-based. You can say that these are similar to APIs that we create, but if we talk about the difference or how it is similar or how it is different from a API that we deploy on an app service like what we saw last week, it has a basic difference in its deployment strategy. An Azure function is when you create the resource in Azure, it is called as a function app. And Azure Function app is something which is created and deployed as a serverless resource. While when you create an API using an app service, it is a shared server resource that you are provisioning and you are deploying that into that, which we saw last week as well, where we deployed our code on an FTP and stuff. This is something which you can imagine as a API endpoint that you want, but it has its own flexibilities and a whole lot of extra elements that are also available with this particular Azure Functions. One of the things that I have also come across while studying for this Azure Functions that Microsoft also gives us an option called Logic Apps. So Logic Apps and Function Apps, these are pretty similar in terms of what they do. They both are serverless infrastructure or serverless resources that allow us HTTP access to different elements. It not only gives, it won't be right to say that it only gives us HTTP access. We can have timer-based access, timer-based events that trigger these functions. We can have manual triggered interventions. We can have some sort of a event based. We can have some sort of a message driven application or function that can be created. So these are all possible in the logic apps as well as the function apps that we are trying to see right now. The major difference that I saw in terms of logic apps and function apps would be that logic apps are more towards more inclined towards people who want to create that same sort of a functionality, but without coding. That's a sort of a GUI access or a GUI portal for logic apps that can be created. You can relate it to something similar which we have in Power Automate. Like Power Automate is something wherein you create your workflows just by dragging and dropping different triggers and actions. Logic apps is similar to that. You create your apps or logic apps and you create your triggers, you create your functionality, but just by dragging and dropping different elements that the the portal provides. But function apps is something which gives you the flexibility as a developer to create your own logic by writing it in any language that you're comfortable in. Currently, uh, Azure Function apps support C Sharp, F Sharp, they support JavaScript. So these are all the languages that you can work on. You can create these in Visual Studio Code for JavaScript. You can use Visual Studio, which we would be using for C Sharp based function apps that you can create. So these are very versatile and flexible resources that Microsoft Azure has provided us, which also, by the way, are quite, if I say, cost effective as well. Because one of the things that you have in Azure Functions is that in terms of deployment, you can deploy them uh, on a compute or usage basis, or it also gives you a flexibility that you can create the app as a function app, but you can deploy it on an app service like what we did previously. So it also allows the container to be very flexible. It can be deployed on a storage container like what we will be doing, which is the default. But you can also, if you want, if you have a sort of a large enterprise level function app that you want, which has its uh, own resource requirements, and if you feel that the function app serverless infrastructure that Microsoft Azure by default provides may not be enough, you if you want, you can have it deployed on an app service as well. But the one thing that Microsoft Azure Function App does provide is auto scaling, which means that the infrastructure that it is deployed on, it automatically scales up or scales down depending on the resource requirements that your app has. So this is something that we would be seeing and how these all would work out. So we will look at some of the core fundamentals of how this Azure function is, what are the different elements, how to create an Azure function app. We will see what are the resources that are required. So those are all the elements that we are going to see. So this particular module of Azure function apps is basically divided into three submodules. One is the exploring of the Azure functions, which we'll do. It will mostly be around what the capabilities of Azure functions are. Then we will see how to develop Azure functions using Visual Studio. We'll be using that. And then we will see one component or one functionality of Azure functions, which is called durable functions. And that is a very interesting topic. And we'll come to that once we reach there. So I'll just stop this presentation right now and jump on straight to the Azure portal and talk to you something about the how to deploy the Azure functions, what are the resource requirements, and we'll just have a look at that. So let me just quickly open up the Azure portal for you. So like last week when we saw how we can deploy different elements in Azure, your portal.azure.com is the place to be where you would come to basically deploy anything that you want. Now, I'm not going to cover again how to create resources, how to create the subscriptions. I'm just going to straightforward go to the portion where what we require, which is the first thing that is resource groups. So first thing that I'm going to deploy or the resource that I'm going to deploy here is a resource group. So a resource group, as I mentioned last week as well, is a very important concept. So when you are creating apps for or resources for different customers, different applications, or if you just want to group your resources into different logical containers so that you can better manage them cost-wise as well as resource maintenance-wise. You create resource groups. I personally like this a lot because I am able to then properly maintain my resources based on why I created them. So this is, I would just say that this is my SkyPiCast session 2 resource group. And the region would be Central India. Uh, that is the nearest to me. So I'm just going to use that. I'm just going to click on review and create and just click on create. So one of the things that I'm doing right now is I'm just creating this resource group first. Why I'm doing that? Because the Azure Function app that we would be creating, that would be done directly from Visual Studio. It's not that it cannot be created directly on Azure portal. It can be, but you will see that creating it directly from either Visual Studio or Visual Studio Code has its own benefits. You get all the functionalities and features that you have in Visual Studio in terms of IntelliSense, code corrections, the scaffolding of projects. All those functionalities just come into the play, and you pretty much are at ease when you're working on Visual Studio because everything is already set up. You have skeleton code that you get. You can just modify those as per your requirements or write your code afresh. So those all things pretty much come into the play. So why I created this resource group first is because when you create a function app, the core requirement of a function app is a storage account group or a storage container. So Microsoft has this very neat feature called storage accounts. So storage accounts basically allow you to store any data. It could be a blob data, a tabular data, file information, anything. And that can be stored into Azure directly with a very low cost. So that is very important. In fact, once you start using Azure Portal and if you want to use the Cloud Shell directly, which is a PowerShell utility that Azure has, and you can just run the commands directly from here. To store those commands and the results, Microsoft Azure automatically creates a storage container for you as well for that because it needs to store the commands, results everywhere. So storage container is a very versatile tool or very versatile resource that is used and a very core component or a required component when it comes to function apps. So that is why I want to create the storage account first. And then when I create the logic apps the function app from Visual Studio, I will have to connect that storage account directly using my Microsoft Azure login credentials, and it should allow me to directly deploy it. And the deployment would be absolutely straightforward. We don't have to do anything. So the next step that I'm going to take is creation of the storage accounts. So you can see that I don't have any storage account right now. I'm just going to click on create storage account. And it should open up a very friendly wizard for me, which just asks me for my subscription, which is the free trial. The resource group would be the one which I just created, which is SkyPiCast session 2. I'm just going to name this. I'm just going to name this as SkyPiCast session 2 as well, just to keep it you basically the name as same. Now, I guess it must be between 3 and 24 characters, only lowercase characters. Okay, I just use some uppercase characters in this. So I'm just going to correct those. And once this is done, the region, I would select the same region which I created my resource group on, which is Central India. And now I need to choose the performance. The performance, basically the pricing tier that you choose. For us, the standard performance would be absolutely something that we can do with. A premium is something wherein you require a very low latency in reading and writing of data. So based on the pricing tier that you choose in a storage account, it impacts the latency of the read-write speeds and a different latency in terms of accessing the data that you have in your storage account. Also, one of the things that you have to do is you might want to choose is redundancy. So any storage account gives you these four options of redundancy. One is a locally redundant storage or LRS, wherein the redundant storage, which is your backup, it is basically stored in the same server infrastructure where your actual storage account is, meaning that both your actual storage data and the backup redundant data are both stored in pretty much the same server infrastructure. So if you want that, and if by any chance your actual or original uh, infrastructure or your storage account or storage hard disk fails, it automatically reverts back to the locally redundant server. It has its own benefits, the benefit being uh, lower costs. Uh, the the cons being that if there is any downtime on the entire data center where your storage account is hosted, and if your redundant storage is also in that same data center, which is the case in LRS, you won't have a redundancy available, or you won't have a backup available, which means that you are losing up on that availability factor. So then there is the option of GRS, which is geo-redundant storage, wherein one of the primary is kept in wherever you have kept it. The other one is kept in a secondary region. So Microsoft Azure has different regions in terms of how they manage their data centers. So if you have kept your primary resource in one of the regions, every region has its own secondary region assigned in Microsoft infrastructure. So what they do is that if you choose the GRS, they automatically keep a backup of it in its whatever region you have chosen. It automatically keeps a backup of the redundancy or the redundant backup on the secondary region of that. Then you have the zone redundant storage, wherein uh, everything that you have, it is always they pretty much give you a sort of a guarantee on a data center level failures, and it is recommended when there is a very high availability application that you're hosting on your storage account. Then we have the geo zone redundant storage. This is even more available option, and it is required where there is a very critical data that is being kept on a service infrastructure or storage account. But saying that, all of these going from top to bottom, from the top, it is less available but low cost. The lower you go, it is more available, more uh, redundant, more uh, failure safe or more fail safe, but they are more costly as well. So for us, since we are doing this as a demo, and these are, by the way, these decisions depend upon how your application is going to be used, or what is the application all about, and what is the deployment strategy. So that entirely depends upon that. So for us, we're just going to use the locally redundant or LRS option and just click on review plus create. Once the validation completes, just click on the create button and just let the deployment complete. While this deployment is happening, I told you about how uh, an Azure function is similar or dissimilar to a web app, and how it is similar or dissimilar to a logic app, which is also something. Now, if I come to the plans of logic of Azure function apps, uh, primarily, there are sort of three plans that function apps have. One is a consumption plan. So when you see a consumption plan, which means that your function may not be running always. It might be that a request comes to it, it processes the request, returns the response, and then it stops. It doesn't do anything else. And it might be that in a day, it only is active for a few minutes or maybe a few hours. So that consumption, whenever it actually works and whatever resources it consumes, you have to pay only for that consumption. So the first and the default and the most common plan that we have in function apps would be the consumption plan. Then there is a function premium plan, which is where that now just one more point to add in the consumption plan is that the consumption plans are auto scaled. So which means that by default they are running as one instance of your function. But if there is a higher demand or higher load onto your function app, it automatically scales to more number of instances. But the only problem in that is if you have one instance running and if it auto scales, it needs some time to warm up. Means that every time it scales up, it needs to create a replica of itself. And by the time the replica gets created, till then you are stuck with that one instance or whatever number of instances you have. So it is not a pre-warmed scaling, which means that every time it can auto scale, but it will take some time for that infrastructure to get deployed, and then the scaling happens. The premium plan in this case is sort of a pre-warmed plan, which means that it automatically scales as well, but you have the workers which are basically going to run your functions, but they are already pre-warmed or already in a ready state whenever you want. And that is why it's called a premium function or a premium plan, and it costs higher. The third option that we have is an app service plan, which means that you pretty much deploy your function app just like a web application in an app service that Microsoft Azure has to offer. So it pretty much is similar to what you have, but the coding fundamentals and the way you create the functions, that is entirely what function apps has to provide. So these are the three different plans that Microsoft Azure Function Apps has to offer. Then uh, there is one more criteria that we have in Function App, which is related to hosting options. So the hosting options, there are two hosting options. One is an app service environment. So when I say that the consumption plan or the function premium plan or the app service plan, these are all basically deployed either on an app service environment, which is separate for a function app, or you also have an option of Kubernetes. So in a Kubernetes hosting option, you have your isolated and dedicated environments running on top of the Kubernetes platform, where your functions are basically running. So these are the two different hosting options that you have for your function apps. Uh, the scalability. The scalability of function apps compared to what we have in Azure Functions is that, sorry, the Azure App Services that we had previously. If you remember the last session, we talked about two ways of scaling in app services. One was a manual scaling and one was the auto scaling. In function apps, the scaling, as I mentioned, is pretty much automatic always. It is always automatic. It automatically scales up and down, and the time it takes to scale up or down depends on the plan that you're using. If, as I mentioned, if it is consumption, it takes a little bit longer. If it is a premium plan, it takes you have your pre-warmed workers which are working. So that is something that is quite good about function apps or Azure Functions. So now that our resources are deployed, let's just quickly uh, see how the Azure functions can be created. So one of the things that I would like to do is, I would like to mention here is that uh, to create function apps, I'll just go through how function apps can be created directly on the portal as well. But I won't be creating that because I usually prefer to do that on a Visual Studio because it's super easy to create that and super easy to deploy. But just because we want to see all the options that we have, I'll just go through the portion wherein we'll see how function apps can be created directly on Azure as well. So I'll just go to this function app option in the portal. If you do not see this, you pretty much can type function app on search on the top. You should see this option. And you click on this, you will have to create a function app by clicking the button, and it opens up the similar sort of a wizard that we are pretty much seeing for all the resources. You choose the resource that you want, you choose the name of the function app that you want, you choose which type of publish it is going to be, like whether it's a code that you're going to publish or is it a Docker container. Then you have to choose whether what is the runtime stack, just like what we saw in app services, whether it's a .NET, Node, Python, Java, PowerShell, custom handler, what it is, what is the version of the stack that you're using. Uh, the version automatically gets chosen based on the runtime stack. Then you have to choose the region where you want to deploy it, what is the operating system, whether it's going to be Linux, whether it's going to be Windows, and then you also have to choose the plan type, like what I mentioned. It's going to be a consumption, which is a serverless, or a functions premium, or an app service plan, which we pretty much saw that time. So you choose all these options, you click review and create, and then you basically create your application. So I'm just going to go through the process and see how it looks in a, there's something missing. I need to test SkyPiCast session 2 test or function 1 if UNC1, and let's just create this. Click on create. Uh, the deployment is in progress. As soon as it created, your resource should be there, and you pretty much have all the options like you have in all the resources in terms of the portal access, and then you can pretty much type in your code and do whatever you want in that. So I'm just going to go through this process to show you how this can be done directly on the portal, but we'll create our action functions directly on Visual Studio. So I'll just go to resource. And in here, you'll see that it's pretty much similar to app service in terms of it has its own URL, the app service plan, everything has in here. Then you have these events that you have. You can create the functions. As soon as you click on the functions, it will show you how many functions you have. So a function app contains the different functions that you want. Now, when you click on create function, you have these options to create, but either you can create a developing directly on the portal. You have these options like HTTP trigger, time trigger. These are all the different types of functions that you can create. You just choose whatever you want and just click on the name, give the name, what type of authorization it needs, and just click on create, and it automatically gets created with a template, and you can edit it directly on here. But as I mentioned, I won't be doing that. I'll be doing that directly on my uh, Visual Studio. So let's jump directly into Visual Studio and see how this can be done. But let me tell you, it's absolutely easy doing it either on Portal or Visual Studio. It's just that Visual Studio allows you those extra functionalities that any IDE comes with. Okay, so one of the things that you need to create the Azure Function apps on Visual Studio would be the workload for Azure SDKs. So how do you install the workloads? If you already have Visual Studio installed and you do not have the Azure options, like if you go to this create new project screen, if you go to the platforms and you choose Azure, so you will see all the Azure related resources that you can create directly from Visual Studio, like the Azure Functions. If you do not see the Azure option, or by choosing Azure, you do not see any project templates, it could be possible that you do not have the Azure workload installed. How do you do that? You go to your Visual Studio installer. So I'll just open up my Visual Studio installer and show you how it can be done. You can check it by opening the Visual Studio installer. Go to the modify screen if it is already installed. If you're installing it for the first time, you will have this option. And in this option, you will see this part, which is Azure development. You should ensure that this workload is checked and it is installed. For me, it's already installed, so I don't need to reinstall it again. If in your case you have Visual Studio installed, but the workload is not installed, you need to do that. If you're doing it for the first time, you just need to ensure that this is checked for any development on Azure. So I'll just close this app. I'll create a function app. I'll choose the all languages. The platform would be Azure. I can see that is Azure Functions. It allows me to create a C# based Azure function. I'm just going to click on this, click on next, give the name, any name. I'm just going to give this SkyPiCast session 2 test function. And it creates your project structure just like Visual Studio does. And just click on create. It will blast you which type of trigger that you want, which is exactly what you saw on Azure Portal, in fact. So the first function, which is the very basic function that we're going to create, is going to be an HTTP trigger, meaning that I'll just call that function and using an HTTP endpoint, and it will give me some result, whatever I create the logic for. But just like since we are on this page, I would just like to take this opportunity to show you what are the different types of functions and trigger-based functions that you can create. So the first one is an queue trigger, which means that uh, you have a resource in Azure called as an Azure queue storage. So as soon as you push data to the Azure queue, uh, as soon as the queue has data, it automatically gets invoked and it starts processing the queue based on the logic that you have put in. HTTP trigger, as I mentioned, is something which allows you an HTTP access to the function app, get, post, whatever HTTP methods you have. Then you have an HTTP trigger with an open API, the blob triggers, timer triggers, which runs on a specific schedule. Then this is the function that we are also going to see later on, which is called durable function orchestration. It's a very interesting functionality that it has. Then you have a SendGrid trigger. SendGrid, for people who don't know or haven't used it, is an email automation service that is available. It is available as a service or as a third-party service. Also, Microsoft has its own integrations as well. Then you have an Event Hub trigger. Event Hub is a Microsoft Azure resource which manages different events and manages different triggers associated with those. Then you have a service bus queue trigger, service bus topic triggers, event grid, Cosmos DB, IoT hub triggers. So you can see a bunch of different triggers that are available, and you pretty much have these options which you can use for any of the predefined functions that you want. And if any of these don't cut the requirement that you have, you always have an option to use an empty project and create your own trigger based on these, one of these, and just use it as per your requirements. So what I'm going to do is I'm just going to use the basic one, which is an HTTP trigger. And as soon as you do that, you see that you need to associate it with a storage account. So to storage account, you see that I need to choose it from this. So I'll just do that. I'll click on browse. As soon as I click on browse, I need to log in into this part using whatever account I have for myself, my account on 366pytech.com, which is a SkyPiCast at 366pytech.com. I have just logged in using that ID on Visual Studio, and automatically with the Azure subscription that this account has, it automatically starts showing me all the storage accounts that I have in here. So you can see that this session, SkyPiCast session 2 storage account, which we created at the very beginning of the session, I created this just for this purpose, that as soon as I start this, it automatically is available to me in here. So I'll just choose this option in here and click on OK. So this just attaches the storage container that we created with the function app that we are going to use. Now, the second option that we need to choose is the function authorization level. So there are three authorization levels. One is a function, one is an anonymous, and one is admin. So function means that your function and its sub functions that are available, only they will have access to this particular function app. Admin means only an admin user which you assign to the function app, only that user can access this particular function app. But if you want to make your function app public, meaning that it can be accessed by anyone from anywhere on the web, you just have to choose the authorization level as anonymous. So that is exactly what I'm going to do. I'm going to choose this as anonymous so that my function app can be used by anyone. I would like to test it directly on my web browser. So I'm just going to choose that and click on create. Once I do that, it goes through the scaffolding process, and you will see that a basic function app would be created for me with the HTTP trigger based function. So it got created on the screen. Okay. So this is it, and it scaffolded one function for me. It called it function one, and this is already done. What it will do is every time I call this, I have an option of a get and a post, and both get and the post can be used for this. And if there is a HTTP post that is available, if I do this function call using a post, I can pretty much put or send any request using an HTTP request object. And that request object can have any parameter. But in this scaffolded function that Visual Studio already has created, you can see that it has used a query string parameter called name, meaning that if I call this function app using a post and I pass a JSON parameter as name, whatever that name value might be, it takes that value as a string variable, and then it sends back a response, with a customized response with that hello, whatever the name is, and this message. But if there is nothing in the parameter, or if I call it using get without passing the name parameter, then it just gives this default message, which is this HTTP trigger function executed successfully, pass a name in the query string or something. So this can handle both the get, both the post, if the post has a name parameter. If not, everything can be handled on this. So it is a basic function that can be created, and inside this function, it is absolutely up to you what you want to do. Your entire use case, your functionality, everything can be pretty much written over here. It's a basic scaffolded function that has been created just for a demo purpose, but you can use it for any purpose that you want. So the purpose of this demo that I wanted to give you is just to show you how these can be created and how are they deployed and work. You can use it for any use case and any logic that you want. So we'll just try to run this function app directly on our local host first, and then we will deploy it on the Azure function. So we'll just run this just like what we do for any Visual Studio application. You will just see that there would be a console that opens up with Azure Functions, and it will give us the URL which we need to open up to actually see what's happening over there. All right, so as soon as this fires up, you should see a URL come up anytime now. All right, so you see that this gives us a function one. It says that it's get and post, and this is the function URL that we have. I'm just going to select this, copy this, and going to open this on my browser, and you will see that it gives me a message, which is this HTTP trigger function executed successfully. Will pass a name in the query string or in the request body for a personalized response. So you can do two things. You can either pass it using a request parameter by passing it name equals, let's say, Azure, and pass it. As soon as I pass a name parameter, you see that it automatically changed the response message, and it says that hello, whatever name I passed, if I just put it to ABC, you'll see that this name changes to ABC, which means that this is now dynamically changing the responses based on the parameter that we are sending. So you can either send the request on a get, or if you have Postman or any other uh, uh, HTTP testers, API testers, you can just create a post request, put a JSON in there, and see this as well over there. So that can easily be done from there. So right now, what we saw is that we just created the function app as an HTTP trigger. And so HTTP trigger means that whenever there is an HTTP request that comes to it, it processes the request and returns back HTTP response in whatever object form you want. So now what we are going to do is, this was basically running directly on my local host machine, but I want to deploy it on my Azure. So how do I do that? So that is absolutely easy as well. So to do that, what we have to do is we have to build the application, which is already done. Then we need to go to publish. And when we go to publish, we would see that there are different options that Microsoft Visual Studio has, one of them being Azure. So I'll just choose this, click on next. In this, I'll see which type of Azure Function app I want to use, whether it's going to be a Azure Function app on Windows, Linux, is it going to be a Function app container, or is it going to be a container registry, which is a Docker image. So I'm just going to use the simplest one, which is Azure Function app Windows. It's entirely up to you where you want to deploy it based on your requirements. So I'm just going to click on next. Now, the same thing what we did for our storage container thing, we are going to do the same over here. We need to choose the resource group that we have. It shows us everything. So you see that I created one function app on Microsoft Azure portal. So that function app is directly coming up over here. So what we have an option is we can directly deploy it to that function. So if you remember, when I created this function app, I did not create any functions. So this is still empty. The function app is created, but I do not have any functions. So what I can do is I can just deploy my function, which is function one, directly over here. And I can pretty much deploy it in here, and I can see how it works. So I'll just click on this. And since it is already there, if you do not have a function app, by the way, you can just click on the plus icon here, and you can create your own function app first, and that would then come up here, and then you can choose that. So it's absolutely up to you. If you have created the function app directly on the portal, you can reuse that. If you do not have that, you can just click on this add button and create your function app first by choosing the subscription, resource group, type, plan type, the location, everything that we did on portal. The same thing needs to be done over here. And then you have that available and you can just deploy this. So I already have this option open. So I'm just going to click on that and click on finish. So once it is there, it is ready to publish now. I'll just click on application publish button on the top, and it will take a few minutes, and it will just tell you the result over here, whether it succeeded or not. So if you are creating your app service from Visual Studio and then publishing, it might take more time than what you would see in here. Because if you remember, when we created the function app on Azure portal, also it took some time to provision those resources. So that would be the time that it would also take from Visual Studio to do the same. Now we see that it is successfully published. So if I go to my Azure portal and just refresh this, I should see that new function come up over here. So you see, this is the function that we just passed in. If I click on this, uh, you will see that. Okay, so this is deployed, and it is says that your app is currently in read-only mode because you are running it from package file, which means that it cannot be uh, edited directly on the portal. Why that is the case? Because we have deployed it directly from Visual Studio, and any changes that want to do, we have to do that in Visual Studio and push those changes directly from here. Now, if you see, we had a URL in here which we used to access our function app, but on localhost. Now, to run it directly from Azure, we have to just use this URL that got created for this function app. Just copy this URL, and in place of localhost and the port, just replace that. So I just need to copy this again, and I'll just replace this. So whatever was there in terms of localhost 7071, and that just got replaced with the Azure for function app URL. And after that, everything remains the same because it's the same function that we have created. And if I just run this, I should get the same response in here as well. So you see that if when I uh, ran it with a parameter, it gave me back the same response that I was getting on localhost. But now the only difference is that it is running directly from Azure. So if I do not pass any parameters, it gives me this default. If I pass a parameter of name, it gives me the parameter value along with a customized message. So this means that our apps function app that we created, it got successfully deployed to Azure as well. Cool. So now I will move on to the last module of our session, which is implementing durable functions. So just give me one second. I'll just convert this one. So one of the things that I would like to discuss with you right now is what durable functions are. So durable functions are basically function apps. If I say that these are commonly serverless applications or functions which are independently running on a cloud platform, and whenever the trigger that is assigned to those, whenever that happens, it works based on the logic that has been set by the developer and returns or does its job and just finishes up. Durable function is basically an extension of the Azure functions that lets you write stateful functions. When we say stateful functions, what does that mean? That when an instance of a particular function is running, it can save its states for later use or later request as well. Meaning that there could be a scenario for an approval, like you initialize an approval process, you initiate a process of approval. That approval requires someone to manually intervene. So let's say that it has a 5-step process. The first 2 are automated, then there is a manual intervention, and based on the manual intervention, the fourth and the fifth step will basically automatically complete. But if you see, The manual intervention is where the entire flow of the application would stop. And how much time or for how long that would stop, that is beyond the control of the application, because that is a human intervention, and a human cannot be as available as a cloud application. So what would happen in that case is that if it is not a stateful function, the first two steps when they get completed, the application or the function is at a state. It has a data, a value, something, and then it is waiting for the action from a user. Until that happens, it cannot move on to the last two steps. So until the user basically gives that trigger, the state has to be saved somewhere. So that's where durable functions extension comes in. And durable functions is actually called as a durable function orchestration. So it basically allows you to use functions app to orchestrate different functionalities or flows. So now there are these patterns that you see on your screen. So a durable function can have these five patterns. The first one being a function chaining, meaning that you have one function, it creates the output, and that output goes to the second function. Second function works on it, creates another output, sends it to the third one, meaning that one function's output becomes the input for the next function, and it goes in as a chain. So this is called as a function chaining pattern in durable functions. The second one is, which you see over here, which is called as a fan out or fan in. What it does in here is that it allows you some sort of a parallelism or a parallel work to be done. Like a function receives an input or a trigger, and it creates workers for itself. Maybe a function one receives the input, and it creates multiple instances of the function two, and each of the function is working on a different data. Now, what it will do is it will wait for all the instances to complete. And when all the instances complete, it basically collects all the results from all the individual parallel functions and then push it to the third function or wherever it needs to do. And it basically then fans in. So first the data comes in, it distributes or breaks it into different workers. They perform the job, and then all the outputs are then collected into a subsequent process that happens. So this is called fan out or fan in. So this pattern is also applicable in a durable functions. Then you have something which is called as an async HTTP APIs. So you can make a durable function as an asynchronous HTTP APIs as well. So there are some scenarios wherein when we make an HTTP call to a API or an Azure function, it is quite possible that the time it takes to process that entire thing and return a response, that may be quite long. And usually what happens is that if the processing time takes quite a long time, your client, which is waiting for the response, get timed out and the connection basically breaks. So in there, what we do is we do an asynchronous HTTP API call, wherein we call the API, but do not wait for the response to come before moving to the next step. What we get in turn for the API is a status URL, which we can just start calling up periodically and see what is the status of the processing. As soon as the processing completes, it gives us back the results, which means that our client does not have to wait for the function to complete. It can continuously check for the status after putting the request. It can continuously check for the basically the status, and as soon as it gets completed, it gets the response back, and that is how it works. So this is one of the app pattern that a function app has. The third one is a monitor. So a monitor function app, how does it work is uh, you can create a sort of a process workflow, like a polling thing, that and when a specific condition is met, you call a particular function. So you create a durable function app, which is a monitor function, which has a certain condition that it continuously checks. As soon as that condition uh, gets is meet, it automatically calls up some other function. So it continuously, rather than some human or some user continuously checking whether that particular condition is met or not, it is a monitor function that basically is monitoring the situation. And as soon as that particular condition is met, it automatically moves into the next part of the function, whichever is written in there. And the third, last one is the human interaction one, which I basically discussed at the very beginning, that you have workflows which have different, like an approval process wherein a function gets a approval request, it initiates the process, then it passes on to the request to a user, a human user, either through an email or any other mechanism like notification or something, and the user then has to either approve or reject it. So based on the approval or rejection that the user basically provides, then the application basically decides whether it needs to go to either the approval flow or the rejection flow. So how does that work? So that is absolutely something which is dependent on the use cases. But these type of app patterns that you can create as a durable function, these are basically called as human interaction patterns. So this is something that I just wanted to discuss with you. One of the other parts which I wanted to discuss before I show you how to create, or how basically a durable function is created, or which I give a demo, I wanted to show you the four types of durable functions that can be created. So the four functions would be, one would be an orchestrator function. So an orchestrator function is where uh, actions are defined and they are executed in an order uh, which you want them to execute. So the orchestration happens, that you create, like what we saw in the function chaining. You orchestrate all your functions to run one at a time, one after another. So that is called an orchestrator function. The second one would be an activity function. So an activity function is what you can say is in an orchestrator function, the unit work, the base unit work, the actual uh, work that is being done, the functions that are actually doing the job, they are called the activity function. So it is related to the orchestrator function. Orchestrator function is the entire function which is orchestrating everything. And in that orchestrator function, individual pieces of work that are being done at a unit level, those are called the activity functions. Then you have functions which are called as entity functions. So entity functions, when we say entity functions, they are basically very basic functions which are mostly uh, responsible for reading and writing very small pieces of information. So if you want a function that just fetches data from a particular source on a DB, or let's say from a particular file, or a particular data source, or call an API. So those sort of small functions which assist the entire orchestration to happen, those are called entity functions. Then you have what is called as client functions. So client functions basically are where you have your orchestrator and entity functions which are triggered by some sort of triggering mechanism, either through an HTTP or a timer or a queue. So these client functions are basically something which get bound with the clients who are calling your orchestrator functions. So the ones who are making the requests and getting the responses, they are basically directly interacting with your durable functions using these client functions. So these client functions basically can be thought of as interfaces which allow you to interact with the orchestrator functions. So this is something which I wanted to just go through before I jump into the process of creating a durable function orchestrator or an orchestration, and see how that can be done. So there are different app patterns, as I mentioned, which can be created for a durable orchestration. We are going to take one such scenario, and one of the most used, or one of the most important scenarios in that case, which I feel is an HTTP async one. So that is something which we are going to create. So to create that, you do not need to create a new solution actually. So if you are creating a solution which requires multiple functions, like one which is a HTTP based trigger and one which is an orchestration. So what you can just do is in your project, just right click and you have an option of add, and then you should see this new Azure function. If you are not seeing this, you can also go to new item, And in here you have to search Azure Function. So you need to search Azure Function. It was already showing up for me. So you can just click on Azure Function. Whatever the name you want to give it, it's already given a default name of function 2 because I already have a function 1 created. So I'm not going to change anything in here. So click on add, and now you need to select a trigger like what we did previously. But this time I'm going to use a durable function orchestration. So durable function orchestration is clicked, and I click on add. As soon as this is created, you will see that just like what Microsoft does very well is it creates a skeleton scaffolded function for you just to test the entire thing. So in here, what it has done is it has created a small function. So this is your function, which basically is doing your activities. So like what we saw in the app function types. So this can be pretty much seen as the activity function. So this is your activity function. This is your orchestration function. So this is basically orchestrating everything. And then you have this part, which is your client function. So as a client, when I want to access this function, I need to call this function, which is called function2 underscore HTTP start. So this is the function. You can change the names as per your requirements, by the way. So when I, as a user, call this function, I do not call the function2, or I do not call the function2 hello. I call the function2 HTTP start, which is the client function for me. Now, this client function in turn is going to basically create the orchestration for the function. Basically, this is the one where it is creating the instance for the orchestration, and it is calling up the function. So this orchestration function is then called. Now, this orchestration function, what it is doing is it is calling up the function to hello, which is your activity function, and it doesn't do anything. It just returns a plain simple string. It receives a value and it returns the same value with a hello message. So if you see, what we have done in here is we are calling the same function thrice with three values like Tokyo, Seattle, and London. So when I call this up three times, it should give me hello Tokyo, hello Seattle, hello London. So three values would be returned. But what it will do is it will only return the output once all of these functions have been completed. And if you see, these functions are called in an asynchronous fashion. Why I can see that? Because if you see, this is an async function wherein the function has been called with an await call. So what it will do is we have created an outputs variable, which is a list of string. So first time the function is called with the value Tokyo, it gets the value hello Tokyo and adds it to the string list. Does the same for Seattle, does the same for London, and calls the three functions simultaneously, asynchronously, gets their data back and stores them into a list of strings. And then finally, when everything is retrieved, it returns it back. Now, this client function, when we call, it doesn't return us the actual output directly. What it will do is it will give us a bunch of URLs and different values. So one of those URLs would be a status URL. And that status URL, if we access it, it will give us the actual status of what is the progress of our actual function execution. If the function has already executed, we should have an output value assigned to that with the actual output of the function. So let's see how that works. So we will do the same like what we did previously. We are just going to run this locally for now. And just going to start on this. The same thing would happen, a console would open up, which is the function getting kickstarted. And you'll see that previously we just had function 1, now we have function 2, but the function 2 is not directly called as function 2, it is being called as function 2 underscore HTTP start. Just remember what I told, that when an orchestration function happens, the orchestration function cannot be called directly, it is being called using a client function. So this is the client function which we saw in the code, which is this one. When I call that up, it automatically calls the orchestration function, the function 2, The orchestration function then calls up this function to hello simultaneously with three different values, gets three responses, collects those responses, and gives us back the result. So if I just run this URL right now, which is the client function API, you will see that you won't be getting a URL directly or a response directly. Let me just format this JSON for you just for easier visibility. I just use this online tool to basically format my JSONs. So in this, you can see that we have a status query get URL, a send event post URL, terminate post URL, purge history delete URL, and a restart post URL. So these are the different URLs that basically allow you to control the orchestration function. If you want to send some value to the event, you can use this URL. If you want to terminate the function, you call this terminate post URL. If you want to purge all history of that particular run of the API or the orchestration function, you call this. If you want to restart it, you call this. But what we are interested in this is the status query get URL, which basically tells us what is the status for our application. So I'm just going to copy that and see what it holds for us. So if I just run this again on a browser, you will see that I will be getting a JSON value again. And this JSON value, if I put in here, what does it give me? It gives me these options, the name, the instance ID, runtime status. It says that it is completed. Until it gets completed, it would say what progress it is still running or pending. Once it is completed, it means that you know that it has completed and you can access the output. And in the output, you see that all the three functions, whatever value they return, it has been collectively put into an array and sent to us. And it also has a create time when the function was created and when it was last updated. So you have all these details available, which you can pretty much use. So what I'll do right now, just to close this session, is just deploy this on the Azure portal as well and just see if it works over there as well. Just click on publish selection. Everything, the publish profile is already created for us. We just need to click on publish and it should go to Azure and we should see the same functionality. But now, rather than localhost, it should be the Azure portal that would give us the results. Just wait for a few seconds for this to get completed. Just waiting for it to be ready. I think it should be done by now. We can just go into the function app, see the functions. If the function 2 appears in here, it means that it is there. Still hasn't. Refresh the page. Yep, you can see that the function 2, the function which is basically the orchestration function, the function 2 hello is the activity function, and the HTTP start is your HTTP or the client function. So these are all in here. So what we will do is we'll just do a quick check of our API. Just go to this function HTTP start, replace the HTTP localhost one with the Azure API. See what happens. It says that function host is not running yet. You see that on the output as well. It is still waiting for it because the application was deployed and now it is running. It says that it is waiting. It's waiting previously. Now if I just try to do this again, just have that restarted. Let's check. Oh, there is one binding which it mentions as missing. Okay, so I need to configure this, which you can see that while publishing, it says that what is the configuration that we need. So we just have to configure this so that it gets deployed. So just click on these. So these have to be deployed as well. So the connection strings for the storage container and everything, they basically have to manage for your application to go. The insights is something which I'm not going to use, so I'm just going to remove this dependency because I don't use the insights for this right now. I'm just going to publish this once again. So you can see that in the console it says publish succeeded, but it is still waiting for the function app to be ready. That is because once the app is deployed onto the Azure portal, it still needs some time to get the services restarted and everything deployed and everything. So that is the time that we have to wait. So let's just see what happens in here. Hope we should be good now. Let's see. Okay. Now you can see that it again gave us the URL. I'm just going to copy that URL which I have in here, and I'll just run that URL to see what the response is. So you can see that I'll just copy this JSON in here and run it. And you can see that it is again giving us the same responses because it's a hard coded responses that we have. So we were not expecting anything else as well. But yes, it is currently running and it is directly running from the Azure websites. So yeah, that is us deploying Azure Functions, durable function orchestrations, and I hope it helped. And uh, thanks for joining. And if there are any questions, any Q&As that you have, I'll be open to those right now. And thanks for joining, everyone.
Uh, Abhijeet, I just have one question, and that is about the async function that you were talking about. So,
Yep.
I mean, thank you for the insightful session, and it was very, very intriguing and interesting to see it in action. The question I have is about how do you design? So, what I understand between orchestration function, client function scenario that you had. I mean, you were talking about durable function, and then async, I believe, is a pattern of an approach. So, with the
Absolutely.
real case scenario, how do you go about it?
So it entirely depends upon what is required. So let's say, for example, this async HTTP pattern that I used for my demo right now, it is one of the most used scenarios wherein we have to perform a long running task. Like say, for example, I want to have a function app which moves data from one table to another, or basically does an ETL job by taking data from a source table, massaging that data, creating some sort of an ETL layer in between, and then transferring the data to some other table, which requires some amount of time. And I want a function app to do that. But I do not want I want to invoke basically through an HTTP trigger, but I also do not want my client to be locked for the duration while that's happening in between. So what I would do in that case is that I create this same sort of a pattern for that, wherein as soon as my request goes into the function app, it starts the process, and but I am not bothered about how much time it takes. I am just given a URL for checking the status, which I can just put into my application as a notification somewhere, wherein I just click, have an Ajax call doing that, checking the status after every few seconds to see if it worked or not. And as soon as that gets completed, or if it fails, it automatically lets me know what is the status of that. So it doesn't hinder in any which ways on my actual client application, but it just does its job in the backend, and I am being notified of it on my front end. On the other side, the other app patterns totally depend on what is your use case and what is your requirement. Like the one app pattern which I mentioned, which was the human intervention. So that is where if there is a workflow that you need to create, which requires a human intervention, you can use that app pattern, wherein some portion of your orchestration is automated, but some portion is driven by a user intervention. So these patterns, which I mentioned, the 5 patterns that I had, they all depend entirely upon what your use case would be. Like for this case, this is an absolutely good pattern, like something which you have in a smart contract. Like in a smart contract, you have something until a condition is met, that contract is in play. As soon as a condition is completed or that condition is met, you do some event. So this monitor function app pattern can be used in those sort of scenarios. I'm not saying it is exactly that, but it's similar, wherein you have create a condition and you ask this monitor to just keep on monitoring it. As soon as something changes, either notify or send an email or do something. So those sort of patterns can be used in there, and these patterns can be absolutely be made flexible. They can be basically mixed and matched based on your requirement. So these are some of the core patterns that can be used.
Thank you, Abhijeet.
All right. Any other questions from anyone? All right. And thanks for joining, everyone. See you on the next session that we will be having. And thanks for joining. Bye-bye.